Well, hello and welcome to today's lecture. So we're going to continue chapter 5, 5.4. Today we're going to talk about factoring monomials from an expression. In this case, we have polynomials. Very well. So for those of you who are following the book, we are on page 329. Okay. So let us review what we learned so far. So recall that we can multiply a monomial by a polynomial this way. Monomial, remember that what was a monomial? A monomial was a polynomial with only one term. By a polynomial. Very good. We have 3x squared, for example, 3x squared times 6x plus 3y plus 4x cubed. 4x to the third power. So how did we do the multiplication? Remember that we take this monomial, this expression right here, and we distribute this monomial into the parentheses, multiplied by the first term, plus the operation stays the same, multiplied by the second term, plus the operation is addition, and we multiply the monomial by the last term, or x cubed. There you go. You have 3 times 6 x squared times x. Remember that x with no exponent, it means that the invisible exponent is equal to 1. There you go. Plus 3 times 3. So let's multiply these two here. X squared times y. X squared times y plus 3 times 4, so we multiply the coefficients, the numbers, x squared times x cubed. There you go. So now we're trying to simplify this as much as we can. What do I mean by that? You have 3 and 6. We can multiply these two numbers, 18. And here you have 2 x variables with different exponents. Recall that if you have x raised to n times x raised to m, you can write one base and actually add the exponents, add the powers, n plus m. Very well. You write one base, 1x, and you add the exponents. 2 plus 1 plus the operation, addition, you copy down the operation, we don't miss the operation, 3 times 3, 9, we copy down x squared, and we have to write down y. There is no way you can actually combine these two. Why is that? Because you have two different bases. The operation is addition, you copy this down, 3 times 4 is actually 12. And here again, x, you have the same base, raised to exponents 2 and 3. So you write one base and add exponents. 2 plus 3. So let me use a different color so you see what I did here. 2 plus 3. There we go. So we have 18 x cubed plus 9x squared y plus 12x to the 5th. And we cannot simplify this more. Why is that? Here you have x raised to the 3rd power. Here you have x raised to the 5th power. They are not like terms. Note that. X to the 3rd and x to the 5th are not similar terms or like terms. So it means that we cannot combine these two terms. course, this term has y in it, and there is no way you can combine these terms together. They are not like terms. So this is what we did before, multiplication. We distributed the monomial into parentheses and tried to simplify as much as we can. The reverse operation is actually called factoring. Now we're going to learn how to factor out a monomial from an expression or a polynomial. Very well. So let us start by one example. We're going to explain factoring through one example. There you go. So in this example, question says, factor completely. Factor completely. What's the expression? Your expression is 15x to the 4th minus 5x cubed plus 25x. Very good. So your first step is to find the common factor, also the greatest one. So step 1, find all common factors. What do I mean by that? What is repeated in all of these terms? What is the number? What is the variable? And what is the exponent for that variable? Let us break each of these down. 15 is actually 3 times 5. 5 is just 5. 5 times 1, you might say. 5 times 1. And 25 is 5 times 5. So what is the number that is repeated in all of these terms? The common number, as you guessed, is 5. So I can factor out 5. So let me factor out 5. I'm going to write 5 outside parentheses. By taking out 5 from 15, 15 divided by 5, I have 3 left. So I have 3x to the 4. The operation, subtraction, I'm going to copy it down. I have 5, which is 5 times 1. I'm taking 5 out of this term. So when you take out 5, you're left with 1 times x cubed, or just x cubed. Now, in 25, I have 5 times 5. 5 divided by 5 gives you 5. So since the operation is addition, I'm going to copy down the operation. I left with 5 times x. Note that you can always check your factorization. You can distribute this 5 back into parentheses and get your original expression. Okay, now take a look at this polynomial, trinomial inside parentheses. I expect you to ask, how about x? Isn't that x a common factor in all of these? Actually, you guessed correctly. X is another common factor. So x to the 4th is actually x cubed times x. X to the 3rd is x to the 2nd times x. And here you have x raised to the 1st power. So let us break this down. This is equals to x to the 3rd times x to the 1st, which is just x. Here you have x cubed, which is x squared times x. And here you have your x written here. As you can see, x is the common factor in all of these terms. What are we going to do? We're going to take out x from each of these terms. So 5, I already took out 5. 5 was a common factor. Now I'm going to write x next to it, parentheses. By taking out x from this expression, I left with 3 times x cubed, 3x cubed. The operation is subtraction. Of taking out x from x cubed, I left with x squared. And now between 5 and x, I'm taking out x and I'm writing x outside parentheses, so I left with plus 5. This is the complete factorization of this trinomial. 5x is called the greatest common factor. Step 2. Write the greatest, G, C, F, the greatest common factor outside the parentheses. Remember that you can always check your factorization by distributing 5x back into parentheses. So let us check this work to make sure we have a correct factorization. We can multiply 5x back into parentheses. Okay, take a look at this. We have 5x times the first term, 3x cubed, minus 5x times x squared, and here you have 5x times 5. 5 times 3, 15, x times x cubed, 1 base, we add the exponents, minus 5, x times x squared, we write 1 base, add the exponents, plus 5 times 5, which is 25x. Do I have the original expression? Yes, it means that this is absolutely correct. Another example for you. Now suppose you have, in this example, this expression, a linear expression, minus 15p plus 20. Question says, factor completely. Well, let us break down the numbers. As you can see, we don't have any variable here. So we're going to break down the numbers. Here you have minus 15. 15 is 3 times 5. So it was either negative 3 times 5 or 5 times negative 3 or negative 1 times 3 times 5. And 20 is actually 4 times 5. You might say, hey, why not just factoring out 5? If you factor out 5 into the parentheses, you're left with 15 divided by 5, which has 3. And don't forget you have a minus sign, negative 3. You copy down p plus 4. Well, another method of factoring this expression is to factor out a negative number. Note that we are interested in factoring the negative number. What do I mean by that? I'm interested in getting rid of this negative sign. So from the beginning, you could say that, hey, I want to factor out minus 5, parentheses, 15 divided by 5 is 3. Remember that we are factoring out the negative sign as well. So we are actually dividing minus 15 by minus 5. So we're left with positive 3p. Okay. Here you have positive 20 and you're taking out minus 5. What was this? It was actually minus 4 times minus 5. Or you can say that, hey, I have 20 divided by minus 5. A positive number is divided by a negative number. We get minus 4. So negative, this is complete factorization of the expression that you have. Again, this is not wrong, but you're interested in factoring the negative number. On the exam and the homework, I expect you to know how to factor out the negative number. Another example for you. Question says, factor completely. Very well. In this example, we have minus 6q squared. Our variable, free variable, independent variable is q, plus 21q, minus 33, minus 33. Very well. So as you guessed, my goal is to take out the negative number. So let's break this guy down. You have 6, which is 3 times 2. You have 21, which is 3 times 7. And you have 33, which is actually 3 times 11. My goal is to factor out the negative number. So first of all, you can say that 3 is common between all of them, but I'm going to take out minus 3. So I'm going to write down negative 3 outside parentheses. Negative 6 divided by negative 3 gives you positive 2 back. 2q squared. You can just double check this. If I distribute this back into parentheses, I get negative 3 times 2, which is negative 6. So far, I'm on the right path. 21q divided by negative 3, it gives me minus 7q. Again, negative 3 times negative 7 gives me back the positive number, 21, which is positive. Now here, I have 33. Negative 33 divided by negative 3 gives me positive 11 back. Don't forget to check your work. By distributing negative 3 into parentheses, you get negative 6q squared plus 21q minus 33, which is actually the original expression that we have. Well, now I expect you to ask, so far you talked about just taking out or factoring a monomial. What if I have an expression which is common in all of those terms? For example, take a look at this example. Factor completely. In this example, I have 3x times 5x minus 6 plus 4 times 5x minus 6. So what is common between these two addends? So the first addend, the second addend. What is common between them? The expression that is common between these two addends is actually this quantity inside parentheses. As you can see, 5x minus 6 is repeated in these two addends. So it makes sense to say that the common factor is this expression, which is a binomial, and we're going to factor out that completely. So in this example, a binomial, it's not a monomial, it's not just one term. A binomial, which is 5x plus minus 6 or 5x minus 6 is the common factor. So since it's the common factor, it happened to be just the greatest common factor, I'm going to take it out, factor it out. So 5x minus 6, you write it outside parentheses. 5x minus 6, don't forget to write it inside parentheses because it's a quantity. And inside the rest of the parentheses, if you take out 5x minus 6, you're left with 3x. So 3x goes here. The operation in between is addition, so I'm going to copy down the addition. If I factor out 5x minus 6, if I take out 5x minus 6 from the second addend, I left with the factor this expression completely. Remember that you can multiply 5x minus 6 back into parentheses and you get your original exponent. Think about it this way. It was like 3x times a box plus 4 times another box. The box, it doesn't matter whatever is in that box, 5x minus 6 or anything else. You can take this box as the greatest common factor, write it outside the parentheses 3x plus 4. This is your box. Let us make it more interesting. Question says, factor completely. Here you have the expression, 3x. I'm sorry, this is 9. Okay. This is 9. Parentheses, 2x minus 5. And you have plus 6, and you have 2x minus 5 squared. What is the common factor between these two addends? The first addend, the second addend. What is repeated in both of these two addends? Very well. Here you have 2x minus 5. You have 2x minus 5 raised to the second power. It means that 2x minus 5 is multiplied by itself 2 times. So the greatest common factor is actually 2x minus 5 itself. So we're going to use parentheses. If I take out 2x minus 5 from the first addend, I left with 9. The operation in between is addition, so I'm going to cut it down. How about this expression? It has exponent 2. 2x minus 5 is repeated twice here. So if I take one of those expression, 2x minus 5, I left with 6 times 2x minus 5. We don't write exponent 2. We took out one of them and we wrote it here, so we left with just exponent power 1 or invisible exponent, which represents 1. This is complete factorization of this expression. Are we sure? How about a common factor like 3? Here you have 9, which is 3 times 3. How about 6? 6 is 2 times 3. Well, as you guess, we can factor out 3 as well. 9 is 3 times 3. 6 is 3 times 2. So as you can see, 3 is also the next factor, common factor. So I'm going to take out 3, write it outside, 2x minus 5. What's left? 1 3 is left. 9 divided by 3 is 3, plus, copying down the operation, 6 divided by 3 is 2 times 2x minus 5. And, okay, let us take a look at this. Can we combine the quantity inside parentheses? If I distribute 2 into parentheses, what do I get? I'm going to copy down 3, 2x minus 5 as the greatest common factor outside. Now I have 3 plus, I'm distributing 2 into parentheses, I get 4x minus 10. Well, I have 2 constants, 3 minus 10, which is negative 7. So the complete factorization of this expression is going to be 3 times 2x minus 5 times 4x minus 7. This is your final answer. One more example for you. Question says factor completely. Factor completely. What do we have here? In this example, we're actually having four addends. Take a look at this. Here you have ax plus, you have ay plus bx plus by. Our goal is to factor completely. Okay, I see 4 addends, 4 terms. The first one, the second one, the third one, and the last one. There we go. Here you have these options. Between the first 2 terms, the common factor is A. A is repeated. So I'm going to focus on the first 2 terms, and I'm going to factor out A. I left with x plus 1. The operation in between is addition, so I'm going to copy down the addition. Between these 2 terms, what's the common factor? Common factor, as you guessed, is just B, so I'm going to take out B. I have x plus y left. Are we done yet? Take a closer look. What is the addend here and here? The addend is A times x plus y, the first addend. The second addend is B times x plus y. Between these 2 addends, what's the common factor? The common factor is a binomial, which is x plus y. So in the last step, we're going to factor out x plus y. Here, if you take out x plus y, you're left with a. So I'm going to write down a here. The operation in between is addition. And if I take out x plus y from the second addend, I left with b. This is the complete factorization of this polynomial with 4 terms or 4 addends. A final example, factor completely, is the following. Here we have 6ab, 6ab minus 2ac. We have 3b squared. And we have minus bc. Very well. Okay. We have 4 terms. Let us try to see how we can start factoring these 2 by 2. There we go. You might say, hey, I want to work with the first 2 addends. Between these 2, what is the common factor? Of course, a is the common factor. Look at 2 and 6. 6 is 2 times 2. So 2a is going to be the greatest common factor between these 2. Well, 6 divided by 2 is 3. I took out a, I left with b. The operation in between is subtraction. I took out 2, I took out a. What's left? C is left. Now for these 2 addends, the operation in between is addition. So I'm going to copy down the addition. Here, I don't have any constants or coefficients or numbers to take out, but I have variable b, which gives me 3b minus, if I take out b here, c. Well, are we done yet? Take a closer look. 3b minus c, 3b minus c is repeated in both of these 2 addends. So now you have these 2 addends with common factor, which is a binomial. 3b minus c. I'm going to take out 3b minus c from both of these, and I left with 2a. Operation is addition, and this is the complete factorization of this polynomial.